Good afternoon, everyone. We'll be starting in a couple of minutes. Thanks for those who joined. We'll start in a minute. Good afternoon, ladies and gentlemen. Welcome to this webinar about design considerations for 500 watts PV modules and the next generation of compatible trackers. Before I start, I'll just say a couple of words in Arabic for our attendees from the MENA region. أعزائي المتابعين، لغة هذه الندوة هي الإنجليزية. يمكنكم إرسال أسئلتكم إلينا باللغة العربية أيضا، وسوف نقوم بالإجابة عليكم باللغة العربية في القسم المخصص للأسئلة في نهاية الجلسة. شكرا لمتابعتكم. So, we kick off the session. This session is sponsored by Jinko Solar, the leading PV modules manufacturer, and Arctic Solar, the leading PV trackers manufacturer, to talk about the new generation of 500 watt modules and how the trackers industry developed also in this direction. The registrations for today's session cross the 1,000 registrants. So if you cannot join this session through Zoom, you can always let your friends and your colleagues know that they can watch us on our social media pages: LinkedIn, Facebook, YouTube, Twitter. And additionally, if you cannot watch the whole session today live, then you can attend the session tomorrow, starting from tomorrow on our YouTube channel. It will be recorded and available for everyone to watch later on demand. A couple of administrative topics. If you can hear me well, then please write me on the chat that you can hear my voice loud and clear, so I know that everything is okay with the voice. I've got okay. I've got Plenty of yeses. Great. Thanks a lot. So unlike this message that you have sent, please send your questions in the Q&A section. That will be the only section that we'll be looking for in the Zoom session to answer your questions. Questions on the chat might be lost because of the lot of messages that we receive usually. And for those who are watching us live on social media, please write your message as well and in the social media as a comment, and our team will be gathering these questions and we will be answering as much as possible of your questions on social media by the end of this session as well. So I'll start to introducing myself. So my name is Munif Barakat, and I am your host today. I'm based in Berlin, Germany. Today it is not sunny as usual, regular winter times in Europe. But would like to start with introducing our first speaker, Mohammed Saadi Dweik. Mohammed Saadi Dweik is a technical services manager for the MEA region at Jinko Solar. He has worked for more than 10 years in the Middle East in the power and energy fields, and he has been involved in technical support, project management, and business development for many countries in the region. So Mohammed holds a bachelor's degree in mechanical engineering and master's degree in renewable energy, and he is also certified solar professional and project manager. So Mohammed will be covering the first part. We'll be speaking about the PV module market trends in 2020, design considerations for fixing 500 plus watt modules, and about the Jinko trackers compatibility project, where Jinko Solar has tried multiple tracker vendors and to test the compatibility with the new generation of PV panels. Our second speaker from Spain will be Pedro Magalos, who is the Director for Global Engineering and R&D at Arctic Solar. Pedro started his PV career in Madrid in Spain back in 2003. So one of the PV pioneers, I would say, in the industry. He started designing and engineering trackers for concentrated PV. When PV was transitioning from laboratory to mass industry, Pedro moved to the USA, and he had the opportunity to deploy tracker solution in the PV market in the US that has been growing massively at that time. Pedro published several tracker-specific scientific papers, and he co-authored trackers chapters of the CPV handbook by Willy. After graduating in mechanical engineering in his hometown of Porto, Portugal, Pedro completed his Master of Science in PV engineering in Madrid, Spain, and he is currently as I mentioned, the Director of Global Engineering and R&D at Arctic Solar. Pedro, with his experience, will be talking in the second part of this webinar about the tracker response to the large 500 watt plus modules. He will be speaking about this tracker panel paradox, and we'll be learning a lot about it today, and then introducing the tracker modularity for project flexibility, which is a very new concept that Arctic Solar has introduced, and we'll be happy to learn about it during today's session. And I think I'll be checking the attendees now. I think the majority of the attendees are online. Then I'll start first with a couple of polls just to know you better, our attendees, please. And then we'll be handing over to the first speaker. So you should be seeing the first question on your screen by now. Well, I'll be asking you kindly to mention what region or country are you joining us from. For those who are watching us on social media, please write in the comments from what country are you joining us. We expect majority to be from the MENA region and a lot of attendees from Europe. Probably I see there are some attendees from the Americas. We're very happy to have people from all around the world, Africa, Australia, and looking forward for an interesting session for all of you. We'll give you 5 more seconds before closing the vote, and then we move to the next question. Quickly sharing the results. So most of the attendees are from the Arab GCC countries, but we have attendees from all around the world. The second poll question is to let us know from what industry you join us. I would like to know in what industry you work. This will help our speakers probably to tailor a bit the discussion today in order to match the best interest of you. I see that we have the majority so far from the EPC industry, next from energy services, O&M, and then from developers. We have plenty from manufacturers and government sector. Give you 5 more seconds before closing the vote. For people watching us on social media, please leave this in a comment so we also know what industry are you active in, and we'll be happy to definitely tailor our content to our attendees. So I'll stop the poll, sharing a little bit the results. As you can see, most of our attendees are from the EPC industry, energy services, and developers, with many people from manufacturers, academia, government sector, and so on. So thank you very much for letting us know from what industries you come, from what countries you come. You are all welcome. We are very happy to have you on board, and I'll be very happy now to hand over without further delay to our first speaker, Mohammed Saadi Dweik, to share with us his experience from PV modules manufacturer perspective, and that's very exciting to learn more about these 500 watt modules. Can you hear us, Mohammed?
Yes, Munif, thank you so much for your nice introduction.
Great.
Assalamu alaikum, good afternoon, everybody. Pleasure really to be with you again, Munif, this year, but this time in English.
Yeah, pleasure is mine.
I know the weather in Germany is not good, but in Dubai, it's beautiful. So I really urge you to visit Dubai.
We would love to. After COVID, the first destination to be Dubai for sure.
You are most welcome. So thank you, everybody. We have seen a very huge interest actually in this topic. And this reflected in the registration and also in the attendance today. I hope we will be able to provide a very new and exciting concept. It will be highly technical, especially from Pedro's side, so be ready. Now, from my side, I will be covering from module perspective, what changes that we have done as a module supplier in order to accommodate and to facilitate the transition to higher power modules. And also we will share a few market trends that started this year or became mainstream this year and will continue for a few years to come. So without further ado, we will very quickly go through Jinko. For the people who are not aware of Jinko, Jinko Solar is a Chinese module supplier based in Shanghai. We have 8 factories, 6 of them in China, 1 in Malaysia and 1 in US. And we are the biggest module supplier in the world in terms of shipment for the last 4 years. Let's hope also we'll be able to reach this target again this year. We have more than 3,500 clients in more than 140 countries. Last year alone, we shipped more than 14 gigawatt of modules. So it's very exciting. This year, we are hoping to reach 20 giga. And next year, we hope to reach at least 26 gigawatt. For the people familiar with us, we used to have many module series. We used to have the Eagle, the Cheetah, the Tiger. But now going forward, we are offering 2 major series, the Tiger and the Tiger Pro, both of them available in 60, 72 cells, and for Tiger Pro, even for 78 cells, reaching the power from 365 up to 585. So a lot of variety in terms of power. Both you will have in bifacial option, either transparent backsheet or double glass. So if you want to know more, you can communicate with our team. We have a biggest team in MENA region for the sales support, marketing, technical, and logistics. So if you want to know more about what we are offering right now, I will be more than happy to communicate with you. So if we see the development of module power class in the last few years, and this is here, I'm limiting, of course, my speak on Jinko modules, for example. We see in 2012, we used to have the maximum power, or the mainstream power used to be 300 watt. And it took actually 6 years, almost 6 years, to have a 400 watt modules. So for 100 watt, it took 6 years to reach or to become mainstream. But actually, 400 watt, it was mainstream even 2019, last year. But now, from 2019 to 2020, we reach, for some companies, they offer 600. So we reach actually more than 150 watt transition in 1 year. So this emphasizes really how important this year and critical this year, 2020, for the solar industry. Of course, that doesn't mean that, you know, there were huge R&D on the cell level, but there were many factors contribute to this transition from 300 in 2012 to 600, almost double the power class in almost 8 years. So in terms of technologies, many technologies were under research and development and has become mainstream, and now it's become market standard actually. So for example, the mono-PERC, which is also called high efficiency mono, and half-cut technology has become a standard. Now all the big, I would say 5 or 6 suppliers in the world globally, with all their new modules, it's mainly mono-PERC half-cut. Even at Jinko, we phased out the standard mono, we phased out the full cell, and we kept our products all mono-PERC half-cut. The industry also was considering poly in many projects, but we see in 2020 for the major utility projects in the region and globally that poly is being phased out as a technology by the biggest suppliers as well, Jinko and others. So this has become a market reality. I know it's maybe in our market, it's not so much welcome, this note, but it's a reality. The polycrystalline modules are being considered all technology. Now the market is shifting into high power, high efficiency modules. Now the developers, the consultants, they are asking for 20 plus efficiency, percentage of efficiency. So this is now the reality we are living. And of course, the number of bus bars, it used to be 2, then 3, then 4, then 5. And 5 was actually last year also mainstream number of bus bars. Now we are going with 9, at least 9. Can also, we are considering, for example, in our modules, we have 9 and 10 bus bars. For others also, they have 11, they have even up to 16. So in this, in terms of technologies, and these technologies really, this shift actually really provided too much and pushed to really the limits, because instead of having a 330 watt polycrystalline module, now for the same area, you are getting 410 mono-PERC half-cut module. So this alone, these technologies shifted and improved the power by 80 watts for a simple 2x1 meter module. But actually the real force and the real reason that the many companies, and Jinko is one of them, be able to offer 500 plus modules is that big development happened in the wafer size. For many years, actually, the wafer size was standardized in the market, and it will be shifted or changed a little bit every couple of years. But in the last 2 years, where the wafer and ingot suppliers were able to offer a bigger ingots, so this actually led to bigger cells in the market. So now the mainstream, for example, this year was a plus 160 cell, although last year it was 158. And next year, actually, the projection, especially for utility, to be 182. And there's another also company that shows 210. So I think the mainstream wafer for utility will be between 182 and 210. Now, Jinko, along with major suppliers like Longi and JA, have adopted the 182 wafer. We see this as a very natural transition in the market. We believe 210 is still a little early for the market to adapt to. And Longi, JA, and Jinko, all of them, they have combined, they have more than 50% of global market share. So we really believe this will be a mainstream wafer size for 1-2 years to come. And we wanted to actually, we signed an agreement because we wanted to standardize the wafer size, so it will be easier for trackers suppliers, for example, like Arctic, to design their new products based on the they will prefer more standardized module sizes. So this is the first and the most important thing in the wafer, but of course, this comes with limitations, especially in the balance of system, like inverters, trackers. Not every company is able to adapt yet to these changes. So we are still waiting. I think by next year, the first half of next year, the market will be fully adaptable and ready for these modules. And anyway, the mass production of these modules will be in Q1 2021. And this is actually the topic of today, how the trackers, for example, like Arctic, being able to adapt and optimize their design and their products to install bigger modules. But of course, there's another issue, of course, of logistics. Always we are being asked the question of when it will stop, this, bigger wafer, bigger module. Is there a limit for that? Are we going to have 3x2 module in the near future? I think it will reach its limit actually by next year, because there are so many limitations, as I said, especially in the logistics. So having a bigger modules doesn't serve the client or the supplier, because the logistic cost will be very high, and not to say, of course, the other obstacles. So that's why we see with the 182 now is a very reasonable transition from 166, for example, to 182. It's easier and more practical for trackers and inverters to really adapt to it. So these are the major trends in 2020. And as I said, 2020 is a very important year in the solar. It has established new standards in the industry. So for Jinko modules, we used to have the 2x1 standard module. And now when using the 182, or it's called in the market the M10 wafers, so actually the dimension will be increased a little bit. So instead of 2, it will be around 2.2 meter in length, and instead of 1, it will be 1.1. And if you go with the bigger modules like the Tiger Pro 78 cells, it will be around 2.4. And some other companies offered bigger modules like 2.5 by 1.3. And there are some companies actually offered like double modules connected to each other. So here come the questions usually of how the trackers can adapt to these changes and why these changes are happening. Now look, first it's in terms of costs, and to offer a more competitive price, the bigger wafer offer a better price. So we can offer from our side a better price to the clients. And also usually the bigger wafer, they have more efficient modules, because when you have a bigger cell, you are eliminating many distance between the cells. So you are actually gaining more efficiency. So before we go through what we have done, I just want to, and how we optimize the design of the module itself, I just want to establish, because you consider this as introduction also to Pedro's presentation. So he will talking about loads and dynamic loads, static loads. So I just want to establish the terminology here. Now the static load, which is called uniform load, is as per the standard IEC 61215, which exposing the module to 3 cycles of loads to 2,400 Pascal in both front and on the back, which is approximately equal, let's say something to 400, 500 kg, depends on the module dimensions. And this called the wind load. And you see the data sheet, it's called the wind load. And you have also the snow load, which is 5,400. So an equal distribution of power, of load on the PV module, like we see here. So the snow load is approximately 1 ton, but it changes, of course, based on the module dimension. So this is the general one which everybody comply with and everybody has it as part of IEC standard. But actually, both of them, the wind load and the snow load, are not accurate loads. Because first, for the snow load, the snow doesn't usually come unified and equally distributed on the module. So if you see here in the middle, usually it's accumulated and on the below edge of the module, short side of the module. So actually there's another special IEC standard for the 62938, where they expose the module to around 50 centimeters of snow for a period of time, and they see the performance. But actually, since this is not so much important in our region, the snow load, because we have a very hot region, this may be more relevant to Northern Europe, Canada, Japan, but not in our region. So actually, this one is not so much important. But the dynamic load on the right here is more relevant, actually, because it has more accurate simulation of wind, how the wind works. The wind doesn't come also equally distributed on the module, and it can hit both sides, front and back. So there's a specific also dynamic load IEC standard. We usually don't do it for all our portfolio, but for some projects we are required to do it, where they expose the module to around 200 kilometers per hour wind speed, something equal to that. So these are when we say static load, what we mean usually as per the IEC standard, where we expose the front side, the back side to different loads. And the dynamic load is the wind load and specific IEC for that. But when we see that in the data sheet, it's mainly under the standard IEC, not the special dynamic and special snow load. So also when we talk about trackers, it's very important to know the main components of the trackers. We have the purlin here, where the modules will be placed on. We have the torque tube, where the motor will be installed, and this will be rotating the table of the modules, the trackers, with the sun, movement of the sun. And we have the post, which will be fixing the trackers into the ground. Of course, increasing the module size will affect all of them. So when we increase the module, you have to increase the purlin, you have to increase the post, and you have to have a bigger motor. And also, it not only depends only on the module, but also it depends on the location. That's why a company like Arctic, they cannot propose two exact systems for two different locations. If there's the wind speed is the main factor there. If you have high wind speed or low wind speed, and this is something also Pedro will talk more about it. It depends also from our side. The fixing will depend really on how the wind speed and what the wind loads is being considered there. So now, how we optimized our frame now? Now, first we have now 6 pairs of holes in the module for bolt fixing, because there are 2 types of fixing, either by bolt or by clamps. So now for bolt fixing, there are for the 400 millimeter holes, the 1100 millimeters holes, and the 1400 millimeter holes. So if you are fixing a low wind speed, we recommend using the 1100 holes. If you want only to use 4 bolts, But if you're able to use 8 bolts or you have high wind speeds, it's recommended to use the 1400, the 1100 and 1400 holes. Now, for smaller modules, you can use the 400 holes. But really, we don't recommend using it for bigger modules, especially if you have, especially when you have high wind speed. Now, on low wind speed, okay, it can be acceptable, but if you have high wind speeds, we really urge to use the 1100 and 1400 holes. And of course, we are getting asked questions because not all the designs of the trackers are compatible with, for example, if you are using a 2P trackers, they will not use the 1400 holes only or 1100 holes. They may use another or combination of both, one here and one here. So, for example, they will use, let me put it on screen. They may use this hole with this one, for example, and this one with this one, because they need to fix, if you have 2P, this will be the upper module, and the lower one, they will use the other holes. So we usually say if you have a specific or special design fixing location, first, the tracker company like Arctic, they have to provide the loads the study analysis they did. And if it's within our limits, the limits of, for example, 2,400 or 5,400, then we can approve that. So we are not limiting ourselves only to these fixing methods, but also if you have another suggestions or another ways, and this we are getting usually asked by many tracker suppliers to comply or to give approval to fix the modules in a specific way, where we usually ask for load analysis report before we do that. So this is the bolt fixing. If you go with clamp fixing, usually there is a distance we recommend. And if you see here, either it's on the short side or in the long side, the distance is something between, sorry, J and K. So this area between J and K is usually the recommended area distance to fix the BV module, the clamps. We recommend using the long side for fixing, and to use at least 2 clamps on each side. Of course, if there's a higher wind loads, we recommend using 3 clamps on each side. There's also many variation. You can, fix on short side, mix of short and long side. So there's plenty of variation. It's all in our installation manual. If there is any special cases, please come back to us and we will see if it's acceptable by us. We will do analysis and we will see if it's okay to go with that. Because it's very important when you don't fix the modules as per our installation manual. So if any problem happen, then it will be out of warranty because you did not follow the recommendations. So it's very important, if you have any fixing method you want, and you see it's not in our recommended fixing, please come back to us. We usually offer a letter for you, if it's okay, of course, to tell you that it's all right. So what we did actually, when all these new modules we have, we did a project with many suppliers. Arctic is one of them, where we installed the big modules in many of their trackers, and we noticed the results, and we actually did analysis. So for Arctic, actually using 450 Berlin or 1150 or 450 Berlin, actually, we're very successful. And the very unique thing that you didn't need additional support. The Berlin alone was enough. While for other trackers suppliers, we needed to add a supplemental rail or bumper in order to withstand the required loads. So now, of course, Pedro will go through what they have done, what they are R&D is considering. So just to conclude, going into the big modules is a challenge for everybody, but this is something we have to move the industry forward, and we have achieved very good results with the major tracker suppliers, where even the wind load was above 2,400. We reached 3,000, and in some cases 3,300. And now we are doing our R&D is actually optimizing the frame to make it stronger and to be able to withstand even higher wind loads. So this is from my side. I hope I could give you the overview of what trends and what's technologies in the market, and also introduction to Pedro. So it's all from my side. It's all good. Thank you so much, everybody, and thank you, Munif. Back to you.
Thank you, Mohammed. Really appreciate this content that you shared with us. It's very interesting to see, obviously, to re-emphasize that this year has been exceptional in the development of PV modules and efficiency, the wattage and the power of modules that have been jumping every couple of months, and we've been seeing numbers like what you had in your screen, 580 watts. It was quick development, obviously a challenge for you as a module manufacturer and a big challenge for tracker manufacturers and everyone in the ecosystem that has been affected by these big modules. And that's why I think it will be very interesting to hear from Pedro now about how is this topic addressed by Arctic Solar, and to learn more about how they adapted to these new developments and what would they recommend to the EPCs, the developers that are here on the call to plan their future projects with these 500 watts plus modules. Pedro, the floor is yours. And
thank you.
Yeah, okay, and we can hear you clearly.
Okay, cool. Can you guys also see my screen?
Yes.
Okay, well. Beautiful. All right, so first of all, thanks for the invitation and the opportunity of disclosing what we have been working on at Arctech with regards to the best tandem between trackers and the large modules that are now the most popular in the market. Munif and Mohammed have given a good introduction, so I'll just pick up from where they left, and there are a few ideas that I'd like to highlight. It's been very, very fast, this change from the old 2x1 modules. In about just 6 months in 2020, we used to be here. If you guys can see my mouse, all manufacturers had like a panel length of 2 meters and a panel width of about 1 meter. And now everybody has pushed the boundaries to larger modules, high power modules, and everybody else in the industry, like us trackers and inverters, and even the EBOS guys had to adapt this change. Okay, so fortunately, we at Arctech are also a Chinese company. All of these major panel manufacturers are also Chinese. We have been in direct contact since I'd say September 2019, preparing for this change. And that's something I'd like to share with you guys today. So here's a real case study. This is a real project, 100 and something megawatt project that we were almost shipping for. In Australia, everything had been designed with a 400 watt panel, a typical 2x1, and then all of a sudden, these guys came and said, "Hey, stop! We have these Tiger Pro modules that come at 530." That provides big savings for us, because we're going to keep almost everything the same, and the power is going to grow by 30%. So that equals to savings. Well, that's correct. In principle, that's correct. But the thing is that the VOC, the voltage of these modules, stay the same. So what does that mean? That means that I have a much larger panel, but I have the same number of panels onto one tracker. What does that mean for the tracker? That means a big change for the tracker. Take a look at this chart. So the tracker all of a sudden used to be, like the footprint you see in the picture, and now it grows this way and it grows that way. So it gets larger on both directions, okay? And what are the implications of that? Well, We all designed these trackers with the size in mind. We all went to the wind tunnel. We all got specific pressure coefficients. We all understand the deflections of a specific size. Now everything is bigger. So this increase in size, affects two things. So, I'll talk about technical stuff, but I think I will put it very plainly. So bear with me for a second. But there are these two worlds with regards to tracker design that we need to explore. Okay, the first thing is like the pressure itself. It's number one. And the second thing is, since trackers are large and slender structures, they tend to be flexible structures. Okay, so we need to always take a look at these two effects: resistance and stability. All right. And that's what this chart shows. You can design a tracker that is, compliant in terms of resistance. That means that it does not get overstressed under design loads, but is too flexible and may not be stable. And as a matter of fact, mind you, those have been the most failures we've seen out there are because of stability or lack of stability, sorry, rather than a deficient resistance design. So how does how do panels impact both this resistance and stability? Let's take a look at resistance first and then stability. Okay, so in terms of resistance, it used to have these vortices, and this black part here is emulating a panel. And these vortices would form when the flows, detaches from the surface. Now, if the panel grows, the vortices are larger, which means that the pressure is also larger. Okay, we've seen this in the tunnel. This is a practical example of our results after increasing from the typical 2-meter panel to 2.3-meter panel. We call that the chord of the tracker. And this specific example is a 1P tracker. So the chord of the tracker equals to the length of the module. And what happened was the torsional moment increased depending upon geometry and depending upon panel, increased from 4 to 10%. So I have more moment on my tracker, but I also have more, normal force, more pressure. Okay. Also about 5 to 10%, but that's not all, because even the dynamic effects increase by the same 4 to 10%, 4 to 9% here. So I have three things happening at the same time impacting my tracker design. I have more moment, I have more force, and I have more dynamic effects. Okay, so that's one thing. The other part is deflection. If you have not seen what an air elastic wind tunnel test looks like, this is it. We at our partners in CPP in Colorado in the United States, we've been collaborating with these guys for like 3 years now, and we've ran a whole program on all of our product lines. This specific test here is one of our latest air elastic tests in our 2P solution. When we look at stability, there are three main modes that we need to bear in mind when we talk trackers. Mode 1 is the twisting mode, is the very first one typical to get excited, but in other trackers, the heaving mode is more important. This is very, very common, the twisting mode in our and everybody else's 2P trackers. It's the first one to get excited. But in 1P trackers that are not as prone to twisting as 2P, you have like strong heaving mode. So you need to look at measures to cope with these things. Okay, and now I'd like to introduce what we are used to seeing in terms of trackers and how things evolved and how things will evolve in the future together with the large modules. So, I'm calling from now on, what we consider a traditional tracker design. So what is a traditional tracker design? It's a long structure with a single fixed point. Okay, so I have a fixed point in the center, and then I have a huge half wing span. I call that span a fixed to free span. So a fixed to free span in a very light and flexible structure allows for a motion like this. This is a twisting mode, okay? The very first one to get excited all the time. Now, let me ask you one question. If the module grows, my fixed to free span, what will happen to my fixed to free span? Fixed to free span will increase even more, which means that this motion, this deflection will also increase. As a matter of fact, it is function of this length. I explained that in a chart there. But before that, another very important concept is what we call the critical wind speed for stability. These two things that you see in the picture here, sounds very complex, but it's not that complex, are instability maps, okay? Let me try to, right. So what you have here is tracker tilt. So if the tracker is at a given tilt, so it's this angle right here. And here you have the critical wind speed in terms of meters per second. What does critical wind speed means? Critical wind speed means it's the wind speed upon which the tracker starts shaking too much. So we really want this critical wind speed to be the highest possible, okay? Because if the critical wind speed is too low, the wind will come and the tracker will start shaking too much and can even, just stuff to maybe start flying away and things like that. Anyways, my point being that if you have a traditional tracker like the one I showed before, you should really get away from the worst point, which is pretty clear here in both charts, that is 0 degrees. So you should never, ever stow your tracker at 0 degrees if you have a traditional tracker, okay? And because if you do, you are in risk of things like this to happen. That's not what you want for your assets, because it costs a whole lot of time and money to go back to the field and fix all this mess. So again, traditional trackers, one fixed point in the center, very long wingspans, get away from 0 degrees, okay? Perfect. Now, let's get back to the large modules. Like I said, this critical wind speed, this instability right there, this value of critical wind speed right there depends upon L and the chord. Now, what happens if L grows? What happens if I go from here to here? My natural frequency comes down and my critical wind speed comes down. It's linearly proportional, okay? So take a look at that. Before, when you used to design the old trackers with or the traditional trackers with the old smaller modules, we would go to our lowest critical wind speed, and then we would say, okay, we can operate the tracker within this area. We don't want to go beyond the critical wind speed. And everything was set by the critical wind speed at 0 degrees. Now, if I make my panels larger, I make my tracker longer, what happens to my instability curve? Look, this is what happens, it comes down. So now all of a sudden, my operational wind speed area is shorter. I cannot operate my tracker in the previous wind speed conditions. So I need to lower my wind stow limit, okay? So here's a practical example. This is last year, 400 watt panels, all trackers. If you're talking about 1P, used to be at 90 meters. Now they are with a 500 at 100, or even some manufacturers have 600 module trackers, and these trackers would go up to 110 meters. And the cords are also very long, okay? So this is directly affecting our, like I said, pressure first and stability second. This thing is coming down and I have 5 to 10% more pressure. So it looks like, oh, the module guys, are doing all these larger sizes to save money, but then I need to put more cost on my tracker. it would be great if we could both go towards the high performance but saving money category, right? So possible solutions here for traditional trackers. Well, you reduce the number of strings per tracker. Okay, what does that do? You used to have, like I said, a very long half wing because this tracker was 3 strings. Well, if I only do 2 strings, the tracker goes up to here. So this is 2 strings there, and the tracker is stable again, no problem. Well, the only problem is that if you go, let's say, from 400 to 500 watt panels here, you see that the possible savings are 25%. And then if I lower from 3 to 2 strings, I seem to be increasing my tracker cost into 30%. So it kind of defeats the purpose. We're not proud of this solution here. So, we used to do this thing like in the very first project that everything had been designed. There was no time to actually go back. The guys changed the panel last minute, so we had to lower the strings per tracker. But this is not a sustainable solution. So another option here is, well, we say, your plant designer or your electrical designer, you guys came with an optimum of, let's say, a number 29 modules per string, versus 3 strings. Now I have, I don't know, 105 meters. Ooh, with 105 meters, I have a very low critical wind speed. So why don't you just reduce this number? Instead of using 29, you use 27. And then with 27, let's say I have, the same old 90 meters and everybody's happy. Well, everybody's happy, except that we are not at the optimum panel per string number. And it should not be on us, tracker guys, to determine what's the best electrical design. Our job is to come up with a tracker that allows your best and optimum design. So this solution, while better than the previous one, is still not what we want to keep for the future. Okay, so right now we came up with a third solution together with our partners at CPP. We really understand not only the full tracker stability, but how stability starts and propagates along the half wing. And what we are doing today with our traditional trackers, because yes, we still have traditional trackers in our product offering, is to do some stiffness increase locally, namely at the end of the tracker. And that puts a little bit more cost on the tracker, like 5 to 10%, but enables the 20 to 25% module savings, which at the project basis is still a good compromise, but it is a compromise. So if we don't want to compromise, what would you do? Well, we use solution number 4, which is what I will present right now in the next 5 minutes. Okay. Like I said, we've been in contact with module engineering and R&D. We prepared for this change and we launched a new, I would say, family and generation of trackers that has been specifically designed for large panels. We'll call them novel stiff trackers, not traditional flexible trackers anymore. Stiff trackers. Stiffness is the word, okay? But before going there, let me present one more thing. Let's talk about the last slides that Mohammed was presenting there. So these are real numbers of pressure tests that we have done with modules and trackers together. And because the module grows, what used to be 24, 27, 3600 Pascal now, increases from 2 to 4%. Okay, maybe this is a little bit more illustrative. I like this chart very much because it's simple and conveys a very important message. Take a look at these 2 possibilities. Okay, the stuff on top of the tracker is my pressure distribution. And I really want to have the lowest pressure possible. As a matter of fact, if you look at the chart here, for the same wind speeds and these 3, very common codes, we calculated the basic wind pressure depends on the wind speed is the same, and we calculated the pressure on the surface at 30 degrees and at 0 degrees. And you can see it's almost double, like 1.7 times or something like that. Okay, so for my panels, if the panels grow, and they have the same thickness of glass and the same frame and all that stuff, if they grow, they're going to struggle with a high pressure. So the panels really want very low pressure. The problem is that if you put trackers at 0 degrees, like I showed before in my instability curves, the tracker flies away. And this is what I call the famous tracker paradox, tracker module paradox. Okay, because this thing here, this position is good for the modules, but trackers are not stable. Here, trackers are stable, but then the modules will suffer. The modules were already at their limits in the previous 2x1, the IC limits of 2400 to 3000. Now, if they get larger, for larger wind speeds, we go beyond 3000 Pascal. So yes, it's not going to be catastrophic in a plant that, you go there one day and see half of the plant is flown away. But sometimes you'll have one string that is not producing as much. You go see, and it's because modules delaminated or, cells cracked or something like that. So what we really, really want and what we achieved in these novel stiff trackers at Arctech was to combine, what's good for modules and what's good for trackers. Okay, that's what I'm gonna show to you. One more note here. Every time, speaking of module pressure, I see, unfortunately, a lot of projects that go there and say, oh, the module pressure is 2000 Pascal. What are you talking about, 2000 Pascal? No. The design pressure is one number, but the minute you get into the solar field, you have a gradient of pressures because the exposure of the trackers is different. And even within the same tracker, like I said, since trackers are flexible structures, you think that this panel right here, you think that this panel right there in this area is seeing the same pressure as this panel right here? Of course it's not. This guy here is probably at 10 degrees. This guy here is at 50 degrees. It's a whole different pressure. So the minute you go buy trackers and you have this tracker guy saying, oh, I have like 2000 Pascal all across the tracker. Get out of here. Are you serious? This is totally different conditions. Okay, so please be aware of that. When we do a project with us, we actually show you a gradient of the pressures, not only from tracker to tracker, but within its tracker. And I can tell you, maybe here, yes, you have like 1000 Pascal or something like that, but maybe there you have 3000, 4000, depends on the wind speed. And that's why the purlins and the torque tubes also change within the same tracker. I will not have the same purlin in this area as I have here. I will not have the same 4 bolts in this area as I have here, okay? So the way to do this properly is you receive the wind speed, you calculate the ultimate design pressure, you distribute your pressures through the field and along the tracker, and you come up with all these areas. And for each area, you have a different solution. This is not a one size fits all, because that would be a recipe for disaster. Okay. Anyways, moving on a little bit.
Yeah. Pedro, we've got 2 minutes left. Maybe if you can choose a closing
very
topic
fast.
from your side. Yeah, thank you.
Very, very fast. Okay, so like I said, we want to combine these two. How do we do that? We need to be very rigid and stow at 0 degrees. Okay, and that's what the stiff design looks like. This is a traditional tracker, a single fixed point, very long, half wing. This is our new stiff trackers where we put multiple points along the torque tube. Okay, this example here is showing 3 fixed points. We've done projects with 3, with 4, with 5. It depends on wind speed, it depends on tracker length, it depends on everything. But that's not the only thing. This is not only about stability. This is also about modularity, right? And this will be the last concept that I want to show you guys. Take a look at this. Now I don't have a fixed point and a huge half length anymore. I have control, I have variables, because now by putting another fixed point here, I have one span that is fixed to fix, and I have a different span that is fixed to free. So what does that allow me? Well, first of all, allows me to get my fixed points and move them left and right and get this fix to fix and fix to free span tailored according to my wind speed. And the second thing, like I said, you're seeing this example here with 3 slow drives and then 2 cantilevers right there. So the stability depends on the individual thing. This chunk is independent from this chunk, which allows me to say, do the exact same tracker with just 1 span here, free, shorter tracker if I have challenging terrain, or if I'm in the Middle East in the desert that doesn't have any hills, and I want to optimize probably even more, I can put 4 and make even a longer tracker. This tracker has the same stability as this tracker and the same stability as this tracker right there. That does not happen with a traditional tracker that is just like this. So if you increase the length, like by increasing modules, for instance, now the tracker is like that. This deflection used to be like this. This deflection is huge like that. Okay, so by having a fixed or several fixed points along the torque tube, I gain control and I can prepare to whichever situation I find. And you have 3 examples here, watch. With this type of tracker, I can put 2, 3, 4 strings per tracker. I can use all panel sizes and even what's coming up right now, mainly in the 500 and the 600 module sizes, because these guys lower the voltage and increase the current. I can configure a tracker with more panels per string by putting these criticiously putting these slow drives along the way. Okay, so that's the last idea. This is just a snapshot, and this is my last slide. So what is the solution to have panel safety and tracker safety at the same time? It's many fixed points, very stiff structure that does not allow the tracker to deflect as much. That allows me to stow at 0, and if it stows at 0, my panel is okay because I have smaller pressures. Okay. Right. So I think that's all I got. This is our current product line. 2 traditional trackers, and the SKYSMART is one traditional, one novel stiff tracker, and we are working on the Skyline too. It's going to be coming out early this 2021, which is also a stiff tracker. Manif.
Thank you, Pedro.
No
it was
problem.
an awesome presentation. A lot of very useful content to give a perspective of how the tracker industry is responding to the new modules. That's very useful. And I've got plenty of questions. I've got at least 50 questions to ask. Probably we won't go through all of them. For our attendees, that's the main body of our webinar that has ended now. We will go for extra 15 minutes just to answer as much as possible of questions that we have received, and then we'll be closing this session. So thank you for all of those that will remain with us during the Q&A session. I'll give you a moment to breathe, Pedro, and ask the first question for Muhammad. Can you hear me, Muhammad?
Yes, Munif, I can hear you clearly, yes.
Okay, perfect. So the first question that I received from Mhandas Marwan Jassim and a few other people that asked almost the same question, like, are bigger modules the way forward to increase the power of modules, with some concerns about having bigger cells means probably more cracking, and bigger cell panels means it's more difficult to fix and more expensive probably, and so on. So that's like a general concern for people or question, like, do you see from Jinko Solar perspective that the bigger modules are the way forward to increase the power?
Yes, Munir, and this is very important question we are being asked nowadays. Now, for sure, it's a way forward, but with some limitations, and this is very important to have because 2x1 meters were standard for many years. Now we are going to 2.2 or 2.4. So there are some concerns in the cell size and also in the module size. The cells will be more exposure to cracks and some losses also because of the bigger cell, and also the bigger module means also more exposed to loads. So now the first thing is we really support improving and oversizing and going bigger, but to some limit, not to be very, going on full force on that. One of the things that's really important, for example, adding multi-bus bar instead of 10 bus bar. This really help to first having a better, more stronger module, and also reduces the losses, internal losses. And the half cut technology really allowed this. Now, some companies also went for third cut. But for us, we see the half cut technology is really allowed to minimize the cracks and to add stability to the module. Now, at the same time, also on the module level, to have a more optimized frame, to have, and also I saw some questions about the frame. The frame is 35 mm for the bigger modules and 30 mm for smaller modules, but it's optimized. It has stiffeners inside. It has a thicker walls. So this all will lead to bigger, to stronger modules. So now the question is, why going into this direction? Isn't like it's more expensive? If you have an overview of the power plant components, you see that having bigger modules will really save on many on many levels. Because instead, if you have like a 6 megawatt project, instead of shipping, for example, 50,000 modules, you will ship 30,000 modules. So you're reducing the number of modules. So this will be reflected in savings on many aspects like logistics, cables, and many others. So yes, I see it's a way forward, but with limitation, not to really go into full force, to take it step by step as an industry. And this is why we went into 182, to take it step by step and to wait for the other suppliers, benefit system suppliers, and also the component suppliers like the glass, the frame, to really catch up with that.
I see. Great. Thank you, Mohammed. Just like a quick question for you, like almost on the same topic from Hamza Yahoul. He's asking if these new modules come with some improvements from the PID, LID, or probably to the gradation
Yes.
improvements in general.
Yeah, we have updated actually our degradation, and this coming because of the gallium doping, of course, not because of the bigger wafer. But now the industry is using gallium instead of boron, so gallium doping allows for better degradation, better or improved degradation. So, for example, last year we were offering Sheeta at 3% first year degradation. Now we're offering Tiger Pro at 2% first year degradation, and instead of having 0.7 annual degradation, we are now offering 0.45 or 0.55, depends on the module. So this is the first thing. Now the second part is regarding the PID. The PID issue, I think the PID issue in terms of from the side of modules, I think it has been greatly under control. But of course, you have to have earthing for the other components as well. But from module side, it's well under control, and our BID values are below 1% degradation.
Okay, great. Thank you, Mohammed, for the answers. I'll go for two questions for Pedro then, before returning back to you. The first one, Pedro, actually, you've seen through like a couple of comments about this, and I've seen through your presentation when you described the traditional flexible trackers as not being able to provide a solution, yeah, and not being fully compatible, let's say, with the 500 or 100 watt modules, or having, let's say, some kind of side effects like increased cost or so on. But the majority of the offerings in the market are of these traditional flexible trackers. So how do you judge this? Like, do you think that we can't use these trackers in the market anymore, or what is your take on this?
Right, that's a good question. So it's true. Mostly in the market, we have traditional trackers, and we can use those trackers. Of course, we can use those trackers, but using those trackers comes with a compromise. If we do things right and we don't want to compromise performance, we must increase steel content. Again, the key word is stiffness. There are many ways to make a structure stiffer. But with the current traditional trackers with a single point, we don't have many variables. So the only thing we can do is to increase steel content, increase thicknesses. So stuff gets stiffer, and if stuff gets thicker, gets more expensive. So yes, you can, but you're going to pay the price. While with the new stiff trackers that I was presenting, you can get to an optimum point, because now you're not stowing at 30 degrees and having a whole lot of pressure. You are rigid enough to stow like that, and the pressure profile is very small. So I optimized my torque tubes and my posts by putting a little bit more stool drives. So again, you can, but you're going to pay.
I see. Just in this case, what you showed in your presentation was like a stiff 2P model. So
Right.
is this concept applicable to 2P models or 1P models as well?
Good. So yes, this concept is applicable to both. Like I explained, in 2P, 2P are more prone to torsional instability. So we started by the 2P. We launched the 2P late this summer, the 2P with many fixed points, but the 1P is coming off the oven right now. We believe at ArcTech that there is space in the market for 1P and 2P. As a matter of fact, we've been the only tracker manufacturer, the big 5 tracker manufacturers, that has done both 1P and 2P. So we don't have vested interest in one architecture or the other. We are both. And we believe that we need to keep being both. So this concept will be applied to both.
I see. Thank you, Pedro. That's good to know.
No
Then I'll move to Muhammad. I've got a question from one of our attendees, also called Muhammad, and he's asking if, like, what is the roadmap, like for the module efficiency as, let's say, officially declared by Jinko Solar. And his second question is just to get a feeling about the impact of these new modules on the BOS costs.
Yes, now the roadmap for efficiency. Now look, the majority of the modules now in the market is a P-type module. More or less within few years, we will reach the theoretical limit of the P modules. So I think also in the coming few years, we will see more N-type modules. And because of that, I think the cost will be lower. But when I say about, let's go talk about P-type only, now last year or this year also, it was 20% efficiency. I think next year it will be between 20.5 to 21% efficiency, especially for utility scale, because it's a very important figure. And I think now when we switch to N-type, we will talk about 22, 23 efficiency, but of course, it will not come in the next 2 years, but I think after that, the N-type will have more market share, and then the suppliers will focus more and more into N-type. And now Jinko, we have our N-type products, but it's limited now. The capacity is limited and the application is limited because of the price difference. Now, the second question about the impact of BOS for the bigger modules, as I said, yeah, the people may look at one module, it's more expensive than smaller modules. But if you look at overall expenses, when you have savings in logistics and labor, because you are having fewer modules, so this will really have an impact. And this actually, we noticed that because we have so many tenders and projects in our region, in UAE, Saudi Arabia, Egypt, Morocco. We have so many big mega tenders, multi-mega tenders. So we see that every consultant or EPC is going for 530, 550 modules, because they did the calculation and they see that if you compare the 530 to 430, for example, the savings are considerable when you go to bigger module, where the savings can, can be achieved in every step on the way, in the logistics, shipping, customs, labor, installation, operation, maintenance. It's all reflected there.
Okay, great. Thank you, Mohammed. Just as a quick question, probably a bit technical, from Nagaraya Mova. He or she is asking if that why the V open circuit is not changing much by increasing module power.
It's mainly the VOC is in big part related to number of cells per module. So if you are keeping the same 72 cells, you will get VOC of around 49. But if you want lower VOC, you can go with lower cells, like 60 cells, where you will get around 40, 41 open circuit voltage. So it's more related to number of cells than the bigger cell size.
I see. Great. Thank you, Mohammed. I'll move for a couple of questions for Pedro now. Pedro, you've got a big fan with us, Abdurrahman Boubraik, who says to master Pedro. No? Since he really enjoyed what you presented, and he's asking you, how can we manage between critical wind speed and the tilt angle to avoid the losses in the energy yield? So about maybe more of a balance between them.
Right. So yes, that's the key question. So like I said, if we want the tracker to be stable, we need to take a look at the minimum critical wind speed, and we can only operate within that critical wind speed. So if that critical wind speed is like, I don't know, in the 40 meters per second, you're safe. It doesn't really matter, right? Because we typically trigger STOW at 18 meters per second. Now with our new Steve trackers, we trigger STOW at 20 meters per second. So from 20 to 40, when the storm comes, it doesn't really matter. Now, if you have a very flexible tracker and your critical wind speed starts getting very, very close to 18 meters per second, that's when you get in trouble. So again, it's about this balance. You need to calculate your minimum critical wind speed, and my recommendation is that you shave off like 2 meters per second below your minimum critical wind speed, and you can operate safely in that area.
Great, thanks, Pedro.
Feel free. I just want to say, anybody that has like these, follow-up questions and would like to entail a conversation with me, I'm always available. It's part of my mission to make this industry better in what I can. So I'm very, very happy to engage with anybody that's wants to have like a quick half-an-hour call or something like that. Just send me an email. I think it's in the
it's displayed on the screen now.
Yeah. Thank you.
No worries. So that's just also like for everyone, like you can see on the screen the emails of both presenters. You may reach out to them because we have received also questions about prices and so on. I think the best way to discuss such topics is also to write an email to the speaker, and then definitely they will put you in contact with their sales teams. Pedro, just a second question for you. I received before 3 days an email from Javed Alam Ansari, who has prepared for today's session and sent me 11 questions. Unfortunately, I cannot go through all of them, but at least we'll ask like the quick ones in the beginning. So he's asking about the maximum length of tracker, and he's asking if Arctic is capable of providing custom solutions.
Right.
Yeah. So if we could get at least these 2 questions answered, then that would be great.
Yes. So I'm just hijacking your screen right here, and I put my whiteboard up, and because I think that the first part of that question is really, really, really important. Everybody talks about tracker length, and it's not random. Why do people talk about tracker length? Because with traditional trackers, like I said, if you can see me painting in blue, you cannot control tracker length. You have one spool drive in the center. So depending on the size of panel or the number of panels per string, it's actually the modules that set this length right here. I cannot do anything but just keep on piling modules. Okay, so that's why people ask, oh, what's the maximum tracker length? That question makes sense in traditional trackers. With the novel trackers I'm talking about, it's not about the tracker length anymore. Okay, so let me explain that better because I was rushing on my presentation. So I have a fixed to fixed length and I have a fixed to free length. So I have limits in my fixed to fix and my fixed to free, and my fixed to fix. And then I can modularize my tracker just by piling up this type of spans, and I can make a tracker that is as long as I want almost. Watch. I keep on doing the tracker and I keep on doing the tracker, but the stability does not get impacted. Why? Because this L1 and this L2 are always the same. There you go, L2 again, L1 again. While in a traditional tracker, I used to have, let's say, L like this, and now all of a sudden the module grows and it's a different L, and I have no control. So I'm in trouble because in this situation, my stability goes down. In this situation here, I have a huge, very long tracker. My critical wind speed, my performance is the same. So the direct answer to you after this long introduction is, in these systems right here, the maximum we were able to get in 1P was around 110 meters, okay? In 2P was about 50 meters, the traditional trackers, but we don't want to do this anymore. We want to install our novel stiff trackers in your project. And here, we don't really care. We look at your topography, we look at your boundary, if the boundaries are challenged, and we will put either short or long trackers that fit your project best. So the second part of your question is, do you customize by project? Yes, that's exactly what we did, because we need to optimize every single dime of that project tracker-wise. So we look at your conditions and we propose the most optimum solution.
Great. Thank you, Pedro, for your answer.
No.
I think it's very informative and satisfactory for the question. Last question for you, very quick one before I move to the last questions for Muhammad. Do you recommend for the audience any book to read? Because I've got this question that the people that want to learn more about the tracker world.
Right. So, you know, as far as I know, we don't have, we should work on that actually, you know, a tracker handbook or something like that. I think you mentioned in the introduction, I participated in what was called the CPV handbook. Unfortunately, that industry didn't pick up as much. So I do not have like a book per se, you know, to recommend to you right now. There are a few papers and a few things that we can share, and you know, our own presentation. So that's as best as it gets. I'm participating today in the IEC committee that is launching the IEC standard for trackers. Finally, we have like 3-4 panels. We don't have you know, a specific for trackers just yet. We are working on that one. So I think that that's going to be the first piece of official bibliography that you can probably use, but you'll have to wait until 2021 for that to come out.
Okay, great. Then I recommend to Muhammad Al-Husseini, who asked this question, to write you an email maybe. And
right.
Yeah, and then if you can send him then a link, then that would be great. Thank you
No
for
problem.
this, Pedro. I'll ask just the last couple of questions for Muhammad. Muhammad, I've got this question from Patricio Galarza, who asked, what would be your recommendation in terms of the maximum fuse size for the higher wattage panels, especially if we're talking about bifacial panels as well?
Yeah, so now usually we used to offer 20 ampere fuse size, but now for the Tiger Pro we updated to 25. So you go with 25 ampere if you have, especially for bifacial, as you said, for new modules.
And this would be sufficient. Okay, I've got plenty of questions that were from people who ask how inverters adapted to the new high power modules. Maybe just to briefly from your side, are you aware about the development in the inverter industry to accommodate these bigger and more powerful modules?
Very quickly, yes, because you know, for every product we have, a new product, we have usually a pilot project with trackers and with inverter suppliers, because these are the two main partners with us. So for inverters, the main issue for the bigger modules is the higher ampere, because now we are reaching 12, 13 ampere per module, a short circuit current. And even for other suppliers, they are 17 or even 18 ampere. So many of inverter suppliers were able to adapt to this changes, like Huawei, Sungrow, especially because since they are Chinese, so it's there's more cooperation. But I also believe like SMA and many other European and American suppliers are also adapting to that. So this is the main issue of the current per MPPT, which should be now above 13 per MPPT.
Mm-hmm. Okay, great. Thank you. I think we won't be able anyhow to answer all of these questions. Our questions are still pouring as we speak now. I think we've covered plenty of these questions. If you have anything more, Pedro and Muhammad would generously answer your emails if you send them an email to the addresses that you see on the screen now. If you have any inquiries about the products themselves, and you can also send them emails and they will put you in contact with their sales teams. For those who ask question about how to select the right module, how about soiling and stuff, we've discussed these in previous webinars. You can always visit our Solar Arabic YouTube channel and view these recordings online. With this, I'd like to close this session sincerely thanking Muhammad and Pedro for the content that you have delivered today. I think this was not just a quick webinar, but more of a crash course of how technology is developing in both the panels and the tracker direction. It was very informative. I have learned a lot from you, and I believe the audience also learned a lot from you. And I hope that this was a very nice closure for this year, for this webinars series, and that we team up the next year also with more exciting topics. Thank you very much. I appreciate everything that you have delivered. Just a quick last then goodbye from you, Muhammad and Pedro, and any closing note from your side?
Thank you so much, Munif. Thank you to Solar Arabic team. It has been a wonderful year working together, and hopefully next year will be even working more. Thank you, Pedro, so much for very great presentation. Technically, it was very also informative for me as well. And looking forward, thank you everybody to your time today, and we will meet again very soon. Thank you so much, and have a nice day.
Thank you, Muhammad. Thank you.
Okay, so I extend my, I basically say the same thing. Thank you very much for your patience, and feel free to email with questions. Always available to talk with people in this, of the industry. Okay, Manif, thank you very much for your great organization, and Mohammed, it was a pleasure to have you as a webinar pal. Okay, so looking forward to the next one.
My pleasure as well. Thank you.
All right.
Thank you.
Thank you. You have been a great team. Thank you. Have a good day, everyone.
Ciao.
People in the Middle East, السلام عليكم. شكرا لمتابعتكم لنا ونلتقي في الويبنارات القادمة. Goodbye.
Goodbye.